Come to the second chapter, the chapter 2, which is called Growth and Decay. Growth means an increasing line or a curve. Decay means a decreasing line or curve. And then we have a third option, which is equilibrium, which just stays solid. Okay, so also we need to figure out all the values for our sequence, and we need to find out what kind of sequence is it is. So let's just go with this one. A rubber ball is dropped from a height of 300 centimeters, so that would be that one there, 300. That's our y, and that is our x.
Hello.
Hello.
Thank you.
And then we have 90% of its previous height. And that percentage should tell you straight away that this is not an arithmetic one, because it is a percentage, and a percentage of a previous one, in our case, it's going to be less and less and less and less and less, despite the fact that it does look linear there, but do not be fooled. Okay, so 90% is multiplied by 0.9, which will give us a different result when we consider our initial height of 300, so that will be 270. How do I know that? Well, 10% of 300 is 30, so 300 minus 30 is 270. Now that our starting value is 270 and we multiply by the same factor, we obviously get a smaller value there. Okay, so that tells you straight away it is the geometric sequence, and we need the value of any term in that geometric sequence is the same as the beginning of the sequence multiplied by the common ratio to the power of n minus 1. Okay, so now if we continue with that one, we know that our initial value is 300. Our common ratio is 0.9, which we can also find by dividing 270, which is the same as Tn plus 1. Remember, the common ratio is Tn plus 1 over Tn. So we do have 270 over 300, and hopefully our calculator will tell us that that is exactly, we need to start with the lower one, 270 divided by 300, because we are going down, right? So there's gravity, so gravity will force the ball to bounce less and less and less and less. So 0.09, which is the same as 90%. Okay, so 90% is the same as 0.9 as a decimal, expressed as a decimal. So we multiply by 0.9 and we use n minus 1 up there, and that gives us the rule for the sequence for the bounce height. How high does it bounce on its first bounce? So we're going all the way down, and as we bounce up, we reach 90% of our previous height, which is 300 times 0.9, which equals 270. Now, how high does it bounce on its sixth bounce? So that's 1, 2, 3, 4, 5, 6. So that's number 6 here. That's a 6th bounce. Yeah, coming up. And our problem is that we cannot consider this one here. We need to start here. So let's just do this the old-fashioned way. Okay, so the old-fashioned way would be we do 300, our initial height, and we multiply that by 0.9, which gives us 270. That's great. So that's here. And I have no idea why this happens, but it is annoying. So now we're up to 270 here. Go back and multiply the 270 by 0.9. And we get 243. That's this one here. 243. And then we multiply that again by 0.9. 2018, let's go with 2019 because no one is that accurate, right? And then we multiply that again by 0.9 and we get 197. 197. We multiply that by 0.9 again, and we get 177. 177, and we multiply that once more by 0.9, and we get 159. Okay, so the answer is 159 centimeters, but now let's use our equation to find that out. Okay, so here it says the sixth bounds. Let's just try that one. T6 is the same as 300 times 0.9 to the 6 minus 1. Let's put that in our calculator and let's see what's happening. So 300 multiplied by 0.9, and then we go to the power of 6 minus 1, and we'll get 177,147. Now that's not the number that we get, that is actually the previous one. So what's happening here? We need to consider that our first one, because it's the bounds, right? So that's not the first bound. So because that is, well, in a way you could argue that's T0. That all doesn't work, okay? So if that's our first bounds, if T1 is actually our bounds, well, then this is T1, and then this one, well, however you want to look at it. So if we make this T1 the first bounds, it's not the term one, the term one is 300. So that becomes term 1. Let's just get rid of that one. So there are obviously two ways of doing that, yeah. So we'll get the right answer either way, it doesn't matter. So that is our first term. That is our second term. So the first bounds is T2, then this makes 1, 2, 3, 4, 5, 6, 7. That makes this T7, and this is where we have gone wrong here. So let's change that quickly around. Let's turn that into a 7, and let's turn that into a 7. And that's sometimes something that you need to look out for, but most of the time that shouldn't happen. So let's do that again. So 300 multiplied by 0.9. And this time we do 7 minus 1, and we get 159, exactly what we were expecting. Okay. How far has it traveled in total by its time that it hits the floor for the 7th time? Okay, so we got down, up, down, up, down, up, down, up, down, up, down, up, down. Let's just do that again. So we have 1 down, 2, 3, 4, 5, 6, 7. So we got 7 downs. 7 downs. And let's see how many ups we've got. We've got 1, 2, 3, 5, 6. We've got 6 ups only. Okay, so 6 ups. Let's do 6 ups then. And we need to multiply that. So the up is the same as the down. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we just add the 300. Okay, in this case we want to look for the series. So we do the series of the, we're just looking at the ups, not the 7, we're not going all the way down. We look at the one that we can multiply by 2, and then we just add at the end the 300 there. So we get the sum of the first 6 terms, excluding the first one, obviously. Then we have our, what is it? Our initial one is 270. Remember, we ignore this one because it doesn't go up and down. What have we got here? Then we do 1 minus r is 0.9, to the n is 6, and then it's 1 minus 0.9. Let's put that into the calculator and see what we get. So we want our fraction symbol there. That's 270. 1 minus 0.9. Oops. 0.9. 1 minus 0.9 to the power of 6. Brackets 1 minus 0.9, and we get that one, and we multiply that by 2, answer times 2, and we add 300. Oops, wrong one, plus 300. Okay, so that should be the total. So, oh, seriously. So that, can you believe it? Woohoo! Interesting. I'm resting on my touchpad, so maybe that's what it is. So let's try that once more. So that's, oh, 1265. 1265, just the downs, multiplied by 2 gives us 2530. That's ups and downs, and then we add the one down of 300, which gives us 2830 centimeters. And that is really it. And if you want to, you could use, no. In this case, it might not be the smartest idea to actually use the graphics calculator, and that's really it.